harder questions about radians. So this is a company, I think this is about optimization, but I'm not sure. Company makes toys for children. The figure 5 shows the design. It's like a piece of cheese. And the toy is modelled, so it's basically a sector, and it's 0.8 radians, and we don't know what R is. And A, B, C, D, E, F are congruent. And the bits that look as though they're perpendicular are perpendicular. And the edges, which edges? Oh, those edges, C, F, A, D, etc. have H. Given that the volume of the toy is 240 centimetres cubed, show that the surface of the area of the toy is given by this. Oh God, right, I've got to somehow do this without making too much. Right, let's think about what the volume is first, shall we? So the volume would be the radians. So we need to find the area of the sector. So area of the sector would be, let's just do, that would be, right, is half r squared theta. And the whole thing, h, would be the thing. And we know that E equals 240 centimetres cubed. And what else do we know? Oh, that's about it, really. So we know that half r squared times 0.8 h equals 240 centimetres cubed. So that's 0.4 r squared h equals 240 centimetres cubed. So that means r squared h equals 240 centimetres cubed over 0.4, which I think gives me 600, but let me see. So that's 600. And then in order to get everything in terms of r, which I'm going to have to do later, we know that h equals 600 over r squared. So that is a conclusion. So that means we've only got one thing we don't know in, also because everything's in r squared, r's over there. Right, next, what bits do we have when we look at, this is not to do with radians, this is just optimization or fun. So in order to get surface area, we need 2 times the sector plus 2 times the rectangle, which is HR, plus that, so BC, and that's something H, so that would be, oh, R 0.8 RH. There you go. Right. Oh, that's fair. So now we know that the area of those is going to be 2 times half r squared 0.8 h and plus 2h plus 0.8 r h. This is not that bad then. Oh yeah, that's fine, that's all of that. And then that means that that's 0. Because the 2 and the half cancel each other out. So that's 0.8 r squared h plus 2 hr plus 0.8 hr, which is 0.8 r squared h plus 2.8 hr. Okay, and now we need to put in the h's, because I don't think I can do anything else with that. I could take the h out the front. No, I'm not going to do that. So it's now 0.8 r squared times 600 over r squared plus 2.8 r times 600 over r squared, at this stage it should start to be, Have I missed something out? Okay, hang on. 2 times the sector. There's no h in the sector, you silly moo. There you go. So that would just take that out. So we've got 0.8 r squared plus, and that's whatever 2.8 times 600 is, which it must be whatever that thing is. So 1680, and that's r over r squared. And then we can take off the squared and take off the r, and that is the answer. I think that was fairly clear. I think I might do one more, just because I really don't think I overly shone there. So this is a stage. The plan view shows two congruent triangles, ABO and GFO, and various things. That's the angle of the stage. The arc length CDE is 27.6. Oh, right, that bit. And AOG is a straight line of length 15, so that's the bit at the back. Show OC equals 12. So we know the arc equals theta times radius, which is OC, or R, and we know that equals 12. We know that equals 27.6. So now we divide 27.6 divided by 2.3 equals, sorry, I just went 27.6 divided by 2.3 equals 12. So that means OC equals 12 meters. And then show that AOB is 0. What's AOB? Oh, so this bit there. Oh, okay, so we've got to show that that's that. Essentially, what we've got is we've got 180 degrees, right? And 180 degrees is pi. So what we're doing to try and find out what that is we're going to go pi minus 2.3, and then we're going to divide it by 2, and that should give us that. Whoops. Minus 2.3 equals, and then divided by 2. So it's, yes, it does actually equal 0.420 something or other, but that's 421 to 3 decimal places. Now I'm going to stop for a bit.